with that, Christine Royce is joining, so I'm going to give her center stage here and take it away. Thank you.
Thank you, Kelly. Hello, everyone. How are you today? I'd like to talk to you today a little bit more about science and STEM and how it doesn't necessarily always have to be a concept diagram. We're always so formalized on ensuring we have a schematic or some kind of explanation. So I'm going to share my PowerPoint with you. Let's get my PowerPoint going. You can see that. So my background is I've taught elementary, middle, secondary school, and now I teach at the university level. And no matter where I've been, everybody likes to have some kind of concept. Well, we have to define the concept. And concept diagrams are things that, you know, they're supposed to describe that idea, that process, or that relationship. And they're good for showing logical connections. But if we think about them, they can also get in the way at points. And that's what we don't want to have to happen. So these three diagrams, illustrations, are actually concept diagrams. If you look at the first one, it's a young student. And there's a lot of studies about what psychologists think associated with how young kids make sense. And if they're asked, they just name subjects or topics in here. But they actually do have an elaborative narrative that they're coming up with as they're drawing it. So it has meaning to them, although that's not necessarily conveyed when it's described. We often get to, middle school, high school, and we increase the depth of diagrams and we have them draw concept maps. And finally, when we get into many STEM fields, we'll put up different things like these interconnections for databases and how things are going to interact in the exact way we want them to interact, hopefully. And that's great, but that's not always what we need to worry about. This is just a really great picture. It's a collection of Manuel Lima's network diagrams to show linkages. And when we think about these, they may be the same, they may be different, and I may put something in a different format than others. So when we think about STEM, we have to come up with what do we mean by the concept of STEM, and then we try to illustrate it. So this is good. We teach each subject. We would love to have every single subject taught for all grades all the time. It's good. This is better though. We have subjects that influence each other, interacting gears. Sometimes one subject is not as heavily focused on as other subjects, but students are seeing how different subjects do impact and influence each other. Finally, this is the best and what the goal of integrative STEM is, where we have the overlapping of these subjects to really try and solve a problem. And this problem could be local, it could be global, it could be something in the classroom, it could be something that even the kids have that you never would have thought would be a problem. So as we kind of consider some of these overlaps and these diagrams, we have to consider that we may all have the same goal, but we may have many different lenses through which we look at that. And that means there's different outcomes. There's not one answer. So I threw up this illustration of a bunch of sunflowers because if I said, give me a picture of a sunflower, different kids, different adults, different teachers might all come up with a different expectation of a sunflower or the outcome. Now, I should warn everybody, if you're ever doing accreditation visits where you have a conceptual framework that you're supposed to have everybody matching on the exact same conceptual framework, the accreditation groups do not necessarily like this approach. They want everybody having the same answer. I offer that from experience in sunflowers. So we have to consider how we're going to actually go on. So I'd like you to participate for a second. In the chat box, identify one local environmental problem that your students or school could become involved in solving, and the content and soft skills that students might need to solve that problem. Now, I will go back and look at these because the presenters don't get to see the chat box as we're presenting easily. But think of one problem as we think about this. And I want to share with you the problem that we worked on, and you've heard Kelly mention a couple times now, in the Philippines, in Cebu last year. And there was a group of teachers from Dave Barnes was there. We had people from ASEE was there. Geraldine Gooding was there. We had people from ITEA, people from the science field with NSTA, and we worked with teachers. And the problem that we provided with them, and we spent a lot of time planning this collaboratively together. The problem that we sat down and wanted to make sure that they could go through and address was a local one. And it dealt with rainwater. The area we were in the Philippines actually had a lot of rainfall, but the problem was it didn't always stay. It would run off, it would cause problems. So the problem we presented was how could they harness rainwater or harvest rainwater and retain it for watering in a community garden. So we asked them to consider it from their perspective. We talked about the science, the soil types. We talked about mathematics. How are we going to measure flow and the rates for flow? And they actually had to go through and figure out with the materials provided how they would design and then measure the flow of rainwater through soil to be able to collect it. Because the different soils had different types of porosity. So in these pictures, you see the teachers trying to plan, trying to measure, trying to figure out the flow rate of water through soils. And as they went through this, their eventual final project was they had to actually construct a way that they would build their fields, prepare their fields ahead of time so they could collect and harvest that rainwater for later. So this integrative STEM approach required the engineering design process. It required the iterations associated with if I put the soils in this format or that format. It required mathematics. It required science. It required a lot of different things. So the teachers saw the local relevance to this problem as they went through. All of that involved the practices. And when we think about the practices, you've heard different people mention the different practices as well. On the left-hand side, we see the science and engineering practices, which come from the next generation science standards. And on the right-hand side, you see the new diagram from the science, technology, engineering, learning standards that Steve Barbado was mentioning. When we think about these apply back to that problem. They had to ask questions. They actually had to plan and carry out investigations. They had to utilize creativity as they went through this. They were making, they were doing. They saw the relevance for the optimism about how it could help their local community. And at the same rate, they had to argue with each other about what they thought would be the best option as they went through. And finally, they also had to consider the ethics associated with it. And that comes into the local environmental problems a lot. So we all may end up having, different approaches, but the students, or in this case, the teachers, all had to actually utilize the same kind of practices. Now, as we go through, us science, math, technology, engineering people, we kind of like the fact that, it's practices in our world. We're good at that. We're really good with showing cartoons like this to what we might consider our people, those science people. Monday was actually Embrace Your Geekness Day. We would probably like that day versus others going, I'm not a geek. I don't celebrate that day. So we laugh at this because, yes, we go out, we identify things, we look at the connections, but it's through our lens, that science and technology, engineering, and mathematics lens as we go through. What we need to do, though, is go into the rest of the world's practices, which are behaviors, which are the skills that we need. And this is where the reality is. So we saw the other day, I think in Dave Barnes's presentation, he mentioned this is out of the STEM, the Power for All, the top 10 skills in 2015, what we need in 2020. And this is important. They start to move, though, away from what we might consider the practices we're used to in the STEM fields. We start to get into emotional intelligence. By the time we get to 2025, we're looking at a new set of skills: cross-cultural and cross-generational competence, interdisciplinarity, tech aptitude. And by tech, it could be tech in any field, even legal aspects of technological considerations. By 2030, we even start to get a little bit further away. So they're not necessarily the practices that we might be comfortable with, but they are the practices that all students need to start to learn how to employ and have as a behavior as the students move through their careers. So this is often a problem. We talk about skills, and from skills we went into practices in the fields. And so we could substitute the word skills for practices and say they're practices for your future. And there's no doubt, this is a great quote, that the world is changing, some jobs faster than others. And when we think about it, we have to make sure we're figuring out how to keep pace for something we don't know yet exists. And there seems to be this tug of war: college versus career readiness. Now, in the end, we want all students to go out and find meaningful employment opportunities in areas that they're best suited for. They may not know they're best suited for those yet because they may still have to learn about them, but we do. I'm at an institution of higher education, and the academic side tends to get a little bit nervous anytime we want to start talking about skill sets and career readiness. And the career readiness side is going, I don't quite get it. We all have to learn. And it's going to be a little bit, I think, challenging as we move towards the future. There's some STEM subject areas that actually require post-secondary training in some area. And there's some STEM areas that might require a college degree. Regardless of where they go to school, all students do need to go to school in order to become better at and have opportunities to increase their knowledge and practices around these areas. The things that we want the students to have, though, are the things that we do not actually measure on tests. So many of the schools you heard across the country were not giving their spring exams because of the pandemic. But I have to wonder if we somehow measured how some of the kids were doing. Were they persistent in continuing their education? Were they being creative and figuring out how to actually do the subjects at home? You know, did they have self-discipline that they logged on? These are those practices, those areas, those life skills that will actually serve them much better as they move into the future. So as we think about this, this is a really long quote, and I've highlighted a couple of words. And I have no intention whatsoever of trying to have people read through all of this, because it summarizes down to the following. It comes from Education for Life and Work, which was released by the National Academies. And basically, the quote in the book has as the premise, education is for the common good and leads to prosperity. Education is to help children meet their future challenges. I don't think anybody would disagree with that. And then it goes into some of the situations that we find ourselves in today. If all of the schooling and informal activities prepare students to meet their full potential. Okay, again, not a problem. This is where the split is. The end of the quote, and I'm going to go back one, talks about what schools are supposed to do, which is master subject areas, and what businesses and political leaders are asking schools to do, which are to develop 21st century skills. There's no doubt we need both of those things as students move into the rest of their life and to help them be successful in the rest of their life. The challenge is, it seems like we're always trying to separate them out. So how do we actually put them back together, think about putting those together, That's the part where the integrative STEM comes in. Now, the interesting aspect is this book was published in 2012. So they did their entire consensus building process. And in 2012, and now 8 years later, we're still kind of having that same argument or difference of opinion or lens through which we look through schooling. Kids are going to be different today. Why do we have to do this? Think of how many times you've been told as a student, I want you to show your work. I had a wonderful math teacher for 6th, 7th, and 8th grade. I was at a Catholic school, Sister Eugene. I tell people she was ahead of her time. She gave kids choices about learning long before that was possible. She used to look right at you and say, you're going to learn this or you're going to die in the process. It's your choice. Now that worked for some of us. It probably wasn't the motivating factor for some others. But why can't kids show their work by live streaming it or putting it on Flipgrid or explaining it in some kind of other way? We have to adapt to what the students are learning and using today. That gets into how we adapt. We have a lot of 21st century skills, all right? You're going to see ones on the right-hand side, which are the 4 C's. Critical thinking, collaboration, communication, creativity. We do all of those things in science, technology, engineering, mathematics, if we set up lessons where they're engaged. On the left-hand side, we're actually talking about more. We have not only the 4 C's, but we also have literacy skills. How do we make sense and discern what's accurate in information? How do we share that information through technology? How do we utilize technology? How are we going to utilize media? And we also have those life skills, being flexible, having leadership, initiative, productivity, social connections. They're all skills that when students are working together to solve a problem, they're going to have to utilize in some way or another. They're going to have to look information up and get past practice and past information. They're going to have to go out and interview people in the community about what might be the problem and how they might be able to solve it. So we can incorporate all of these 21st century skills into exactly what we're looking at in terms of subjects if we find a way to integrate it. Education for Life and Work also showed 2 overlap maps. One was for mathematics. What skills showed up only in the math documents and what skills showed up only in the 21st century skills documents, and which ones overlapped. And you can see that there's a strong overlap. If we go back to the Philippines, the teachers there had to utilize systems thinking. They had to think about what are all the different components within the water cycle system in that area that would allow them to help solve it. They had to collaborate and use teamwork. They had to have disciplinary discourse of what they knew about their area. Some of the teachers came from different parts of the Philippines, and therefore they had different soil types. So they were actually trying to figure out how their information connected. Science and engineering, same idea, what the overlap is. They were doing some critical reading. We provided them a handout where they had some information about the different soil types, the basic information as we went through it. They had to do some non-routine problem solving. And in honesty, we all kind of went to the hotel like we would normally do at a conference, and we had all of these materials. And it was a novelty to the staff at the hotel we were at in the Philippines because they were used to rows of tables and people looking forward. And now you have 6 people from America who are loud and in there going, no, we need tables and we need dirt and we need soil. And they're trying to tape down plastic sheets so we wouldn't trip on them. And it was a very different way. But once the teachers got involved, they were engaged. All right. That also had an example of cross-cultural relevance. Even learning that the teachers might not be engaged at first because of their format of schooling and how we might get them engaged. So we want to make sure, as we think about it, there's a synergy when we're talking about integrative STEM. That synergy is that exact diagram we started, but then we have all of these linkages and connections between the practices and the 4Cs and the soft skills and the relevance to the community that somehow interact. And we're back to one of those concept diagrams that become one of those where you go, so I don't know what you want me to do with this. This is why giving people an opportunity to develop a concept diagram from their own understanding, and by people I mean the teachers, the students, the administrators, the business people, and then having some kind of discourse around that will better enable us to get integrative STEM education going. If it's something that they have to do or figure out, it's going to be more challenging. But if you sit down and let them start that conversation, it's going to be really exciting when you think about it. So as we think about it, the excitement is also sometimes scary. One of my favorite cartoons, sure, I'm scared, but the ichthyologist in me is kind of thrilled too. Yes, we are going to jump into the deep end of the pool, or perhaps that ocean with those sharks, and it's going to be a little scary. But it's also going to be exciting as we consider what's going on and what we can actually help to build collaboratively among all the groups. So at the end, I'm going to go back to the sunflowers. You have to be stubborn about your goals. And the goal might be to get that integrative STEM education into your classrooms, into your schools, but flexible about the methods by which you do that. Because remember, we all have different lenses: the science teacher, the math teacher, the engineering teacher, the technology teacher, the English language arts teacher that you might bring in. We're all going to have different methods to get there, but we've also figured out what that final goal is and what it looks like to us. So with that, I'm going to end and stop sharing my PowerPoint and come back and see if there are any questions or discussion points that are in the thing. So, do we have any? Here we go. We're going to slide down. Any problems? Some people have been talking about Tinkercad, tying in together essential skills. All right. So if there's any questions, we have a couple minutes before I think I'm done with this. I'm happy to answer them, or you're also welcome to reach out and contact me via email or Twitter or something like that. I'd be more than happy to share ideas or resources that we utilized when we were in the Philippines together. I'll give it a moment because I know the typing takes a few seconds. No? All right. Well, ultimately, I hope everybody, can you share my email? Yes, I'm happy to share the email. Please do not laugh at me as we're at a technology conference. I have had AOL since 1995, and everyone on the planet has it, and I do check it. So it works for me. I've got 5 other emails, but that's the one I tend to go to first, so I'm happy to share with it. How do I handle a school atmosphere that is old school and so far away from what you are suggesting? Well, the politically correct statement is trying to open a dialogue and have a conversation with your peers. Sometimes it's going to be some trade-offs. They want to try something. You want to try something. Can we come to a compromise on how that might overlap somewhere? The non-politically correct statement might be, it just might need to be where you try something and the kids get really excited and engaged about it, and then they go to other classes and they're talking about what they did in your class, which could be a challenge. But I think that's one of the ways. I'd start with the having conversations. And I'll be honest, this new pandemic situation is going to be an opportunity to really change some things. I think having teachers try and do some collaborative planning where subjects are integrated is going to take a lot of pressure off of everybody. So it might be an opportune time to actually grasp that and try it out. So having my first initial and last name on AOL is cool. Yes. Yeah. Now you have to pick new names because everything's used. So shared. Absolutely, Carmen. I am going to send the presentation to Rosa, and Kelly had asked that, and somewhere they're going to be posted, but I'm happy to share that presentation with you. So, and I see Kelly's come back and joined me. So, hi, Kelly.
Hi. So today's our day of technology glitches. So it is what it is. But yes, we will be taking the presentations. We'll be sharing them on the STEMleadershipalliance.org website. But you know what? If you cannot find Christine's email, she is always on Twitter. She is our Twitter queen. So I can't thank her enough. And, you know, this is someone that you definitely want to have on your contacts list because she is a wealth of information.
And if I don't know something, I will send you to someone who does. So I'm happy to help out. But thank you, Kelly, for inviting me to join. And thank you, everyone, for your participation. And I will see you back on the participant side.
All right, great. Thank you, Christine.